In this lesson, we are going to be looking at the series and sigma for arithmetic and geometric sequences. So you can see that you have on your front of your notes, I have some things kind of highlighted here. Sorry, one more back. Series is the sum of the terms of a sequence. So you'll see that they use this symbol right here. And then an arithmetic sequence you can look at right here where we list the numbers that are being added, and here's the geometric sequence. A series is when we actually are adding those numbers up. So instead of having them just listed, we are plusing them, is that even a word? We are adding them. And same with geometric. So when you look at the symbol for sigma right here, that's the symbol, it means to add or to sum. It's a summation symbol. S sub n right here is the sum of the first n terms. So let's say we wanted the sum of the first 15 terms. We would say S sub 15. That's what we're looking at. On your formula sheet, which you haven't used these parts yet, but we're looking for sums. There's two different formulas you're given for arithmetic and geometric. Using the sum formula, that's this first one here, both for arithmetic and geometric. And then the bottom one is something we'll do on our calculator, and that's sigma notation. And we have a spot in our calculator that does that for us. Notice, if you're looking, that this looks similar to a formula we've already used, right? That's when we're just finding certain terms. So that should hopefully be familiar to you. So to start, we're going to find S sub 30 for this series, meaning we want to look at this sequence that's given to you in red, and we want to add up the first 30 terms. So our formula, from our formula sheet, again, you'll always be given this, is right here. So I would need to know these variables to figure this out. So let's see what we already know. If I'm looking here, I can say, do I know Sn? I know I'm looking for S30, but I don't have a value for that. Like that's not, I don't have the number. So that's actually what I think my variable is, right? Do I know n? Do I know how many numbers I'm looking for? Yep, n is 30. So that's 30. Do I know my first term? A1. Looks like 2, right? Do I know the value of my 30th term? Meaning, when I list all the numbers up, A sub n is the 30th term's value. Not all of them added up, that's S sub n. A sub n is the 30th term. And I don't think I know that. So that's another variable. So that's a question mark here. And that's all I need, right? There's nothing else listed for variables. So can I find A sub n? Well, look at your formula sheet. The first formula under arithmetic is this formula here. A sub n equals A1 plus n minus 1 times the common difference. I do know all of this, so I can find the 30th term. That's what we're looking for. A1 is 2, n is 30, and my common difference here looks like I'm adding 2 every time, so my common difference is 2. If I simplify this equation, oops, sorry, plus sign, 29 times 2 is 58. 58 plus 2 is 60. So now, instead of having a question mark here, I know this value is 60. So I have all my variables figured out except the one I'm looking for, which is S sub 30. So to now apply this, I'm going to go S sub 30 equals 30 times 2 plus 60 divided by 2. So when I do that, 62, right? Times 30 divided by 2, when I plug all that in my calculator, I get 930. So what we found is if we kept going with this sequence, plus 10, plus 12, plus 14, for 30 terms, if I add all those numbers up, I get 930. Now you can see at the bottom of your notes you have a calculator screen. So here, I'm sorry, let's get this. Instead of doing it the way I just showed you, the other formula that's in your notes underneath arithmetic is the summation formula. And it does describe what you have here. This is the first term to be added that goes here, and the last term to be added that goes here. So on my calculator, I'm going to say x equals, my first term is 1, my last term I'm adding is 30, and then I'm going to plug in this formula right here if it's arithmetic. That's what's going to go right there. If it's geometric, I use that. So to apply that to our first problem, we're going to go on our calculator, and I'm going to go to math, 0. And that's the summation button. Looks a lot like what your formula sheet looks like, right? So a lot of times we'll use n here, but instead of that, since the variable doesn't matter on our calculator, let's just use x because it's very easy to pick. There's x. So when I plug in x here, I'm looking from the first term, and then I'm going to arrow to the 30th term. I'm going to arrow, and then I'm going to plug in the formula from my formula sheet on the top. So it says A1 plus N minus 1 times D. So my first term in this problem is 2, then plus, parenthesis, X minus 1. Now, a lot of you are going to want to put a 30 in here, in the X spot. We never put a number in this spot. The way the formula works on our calculator, the calculator automatically plugs that 30 from the top of the summation symbol in there. They don't want you to plug it in, it'll give you a wrong answer. So always keep this a variable. And then we'll times by our common difference, which is 2. Now when I hit enter right here, I should get 930, which is our answer doing it using the other formula. And when I do, you see I get 930. So that's how we would use our calculator to do this. To go back now, we're going to keep applying this. We have a new series for number 2. It says using the first 50 positive odd integers. So let me just write out what that sequence would look like here. 50 positive odd integers. So the first one would be 1, and then we're going odd. 3, 5, 7. You can see how that sequence would continue. So I'm going to write this series in sigma notation. That's this one right here. So sigma notation is I'm going to use my summation symbol. N equals my first term. And I'm adding the first 50, so the top number is 50. And then I'm going to plug in this part of the formula right here. So A1 is 1, that's my first term, plus, and I'm going to keep this N minus 1, remember we leave it a variable on our calculator, and then times D, our common difference is 2. So now, part B says find a sum. So I'm going to go to my calculator and enter all of this. So on my calculator, I'm going to go math, 0, x, 1 to 50. And then our first term is 2. Sorry, I just put my notes. See, my first term is 1, excuse me. Plus, and then parenthesis, x minus 1 times our common difference. When I hit enter, I get the value of the first 50 terms. So if you add the first 50 odd numbers that are positive, I would get 2,500. So when I come back to my notes, I'm going to put 2,500 right there, because that's the answer. So this is the work, and then you can just get the answer from your calculator. In number 3, it says find the first term. So we're finding a 1 of a geometric series for which the sum of the first 8 terms is 765, and the common ratio is 2. So here's the formula for geometric, and I'm going to see what variables I know. I know that S8 is 765, so that's going to go right here. Do I know my first term? Nope, that's what they're asking me to find. I know R is 2. Do I know N? Well, that's right here. S sub 8 is how many terms there are. So N is 8, and then down here R is 2. So I'm just going to plug these numbers in a little more formally here. So 765 equals A1, which is what I'm looking for. I don't know my first term. So there's what it looks like when you actually plug in all the variables. If you get to this point and you have 2 variables, you go, oh, I need to find something. So there's sometimes 2 steps to these problems. This one has 1 step because I only have 1 variable. So from here, I'm going to go ahead and simplify using my algebra skills. If I take 2 to the 8th, I get 256. And then 1 minus 2 is negative 1. I would choose 2 times both sides by negative 1 here. So I have negative 765 equals A1 times negative 255. I went ahead and took 1 minus 256. So in order to solve for A1, I would divide by negative 255. And when you divide that out, you get 3. Your first term is 3. That's what the question was asking for, so I just gave it the answer. When I go to the next one, it says find the sum of this series. So first of all, I have to decide if this sequence or series is arithmetic or geometric. So when I'm looking, I'm seeing that I'm going from a positive number to a negative number, positive 2, negative 6. So I'm going to say it's geometric, and it looks like I'm timesing by negative 3 here. So my R is negative 3. So those are the 2 formulas we would use. We're going to show how to do both, the sum formula for geometric and the sigma. I would not ask you to show me both on your test. I would ask you to just pick one. And so you get to choose which formula you like better, but I would try both for a while because sometimes one is easier than the other. So you should be good at both. So when I'm looking at this, my variables I need is I need the sum of the first, I don't even know how many terms, right? I have no idea how many terms I'm looking for. So I don't know SN. I know A1 is 2, so I can go ahead and I can put a 2 in right here. Do I know R? Yep, I know R is -3. So R, that's -3. So that is -3. Do I know N? I have no idea what N is, right? I mean, I don't know. I don't know. I know that this is the value of that term. So this is AN right here, not SN. It's not the sum of them, it's AN. But I don't know what N is. So now I need to find N. N is something I need to find in order to do this problem. In order to find N, I think, is there any other geometric formula I can use? So the only other geometric formula that's not up here right now is the one we've been using, which is this formula right here. Do I know AN? Oh, yep, I do. Look at that. So I'm going to go ahead and plug that in. 118,098. Do I know A1? Yep, I do. It's 2. Do I know R? Yep, -3. And then N minus 1, I don't know what that is, but that's where I'm at. So now to solve this for N, notice that N is in the exponent. When N is in the exponent, I'm thinking I might have to use logs, right? Maybe, I don't know. So when I have variables in exponent, that's normally when we use logs, right? So here, I'm going to go ahead and get this by itself, so I'm going to divide both sides by 2 to get that -3 to the N minus 1 by itself. So 118,098 divided by 2 is 59,045. One thing I'm thinking is, and I don't know if it is, but I could maybe find a common base. If I could make these both be a base of -3, couldn't I set those exponents equal and solve, as we learned in chapter 10? So I'm going to see if -3 to some power equals 59,045. So on my calculator, I'm just going to go ahead and go -3 raised to the 6th. I don't know. Okay, that's 700, not even close to 59,000. I need to get higher, right? So let's go -3 raised to the 12th. Oh, 500,000. No, I'm too far. Let's try -3 raised to the 9th. -19. Okay, I'm better. 19,000. Let me just try to the 10th. Boom, there it is. That's the number I'm looking for. 59,049. So I can solve this using common basis. -3 to the 10th is the same as 59,045. So I'm going to write this as -3 instead of a question mark to the 10th. So now, if I have common basis, I can set my exponents equal and solve. Add 1 to both sides. I just found N to be 11. Now I did all that work, and I still don't have my answer because I was missing a variable. So now when I come back up here, I know this N is 11. So now S11, we're looking for the 11th term, equals 2 times 1 minus a -3 to the 11th divided by 1 minus a -3. So now I need to solve this equation. So I'm going to say S11 equals 2 times 1 minus -3 to the 11th. I don't know what that is. Let me punch it in my calculator. -3 to the 11th. So it's -177,147. So I'm going to go back to my notes. That's -177,147. And then divided by 1 minus -3 is 4. So now, I'm going to go ahead on my calculator and take 1 minus a negative, 177,147. And I'm going to, when I do that, I'll end up adding, right? So it's really 177,148. I'm going to take that times 2, and I'm going to divide by 4. So when I do that on my calculator, I would get 88,574. That's what the 11th term is added up. So now, we're going to do that same problem using our sigma notation. So when you come over here, I'm using this formula now. So this is all done on my calculator. It's going to be summation from the first term to the 11th term. A1 is 2, R is -3, and it's N minus 1. We can leave it N. So now when I go to my calculator, I'm just going to clear this so it goes up higher for you. Math 0, x equals 1, and I'm going to the 11th term. And then I'm using my formula for geometric, so A1, which is 2 in this problem. Right? Yep, 2. And then I'm going to go parenthesis, -3, parenthesis, raised, and then again, this variable of x, or n in our formula sheet, does not get plugged in. I know it's 11, you don't plug it in. And tomorrow I'll remind me to tell you in your formula sheet that we can write that down on there so we don't forget that. So now when I hit enter here, I better get 88,574. I should get the same answer no matter which formula I use. Oh, same answer. So now, when I go back to my notes, I don't have any other work to show here. I show 88,574. This is my work right here. There's my answer. So that's kind of the bulk of what we're doing. I want you guys to try number 5. Number 5 is a little bit harder, but it's very similar to number 4. So if you could pause and try 5, then I'm just going to go ahead and write it up here for you. So this one we again don't know n, so I have to find that first. I'm going to try to find common bases again. So -1/6 to some power, I'm hoping. I'm just going to raise it to the 5th and see what happens. Too big, so I'm going to try the 4th. There it is, 4th power. So when I come back here, I can say that -1/6 to the 4th power is the same as 1 over 1250, or 1296. So now that I have a common base, I can set those equal, and I can find that n is 5. So now, when I come back up here, n is 5. So you can choose to use arithmetic or geometric here. I'm going to show you both, just make sure you have it down. So we're looking for S, 5. A1 is 7776. 1 minus -1/6 to the 5th power divided by 1 minus -1/6. So as I go through and simplify this, I would do all of this on my calculator. 1/6, -1/6 to the 5th, I'm going to do it on my calculator. So I get that. Oops, what's something wrong? Sorry. Oh, I put the number there. To the 5th. Okay, I get that number, and then it's going to be 1 minus that. So 1 minus this number. And then I'm going to take that times 7,776. And then I'm going to divide it by 1 minus a -1/6. So when I divide it by 1 minus a -1/6, that's really adding it. So it would be 7/6. You can do that separately if that doesn't make sense. And I get 6666. So my summation, S sub 5, is 6666. That's using the sum formula. Using the series formula, I would say from n equals 1 to 5. And then I have 7776 times -1/6 to the n minus 1. There's my work. On my calculator, I'm going to go math 0 x 1 to the 5th. Oops. I made it push enter. 7776 parenthesis -1 divided by 6 parenthesis raised to the x minus 1. There we go. When I hit enter, I get 6, 6, 6, 6. So either way you do it, you get the same answer. And if it doesn't make you do it a certain way, you can choose any way you want. Okay, that's kind of the bulk of the lesson. These next two problems are a little bit easier. We're going to look at some Excel math stuff. So as I move ahead here, it says write as a sum of terms. So you're going to be given this, and you have to figure out what the sum of the terms are. So I'm looking, and this is the first term is 4, and the next term is 8. So you're going to plug in a 4, in this case j equals 4. Then you're going to plug in j equals 5, j equals 6, j equals 7, j equals 8. That's what you're substituting in. So I'm going to go ahead and I'm going to substitute in a 4 in that spot. So I'm going to write 2 times 4 squared minus 3. That's the 4, that's j equaling 4. Plus, because it's a summation series, so let me change colors right here. Plus, and then I'm going to do the 5th. So that's this one right here. So I'm going to go 2 times 5 squared minus 3. Then I come back, plus. Then I'm going to do this one right here, 6. 2 times 6 squared minus 3. Plus, see the pattern here? Then I'm going to go 2 times 7 squared minus 3. And the last one is 8 because it said 4 to 8. That's why I'm choosing to stop at 8. 2 times 8, well, I should switch colors, sorry. Squared minus 3. So this is how you write it as a sum of terms. Sometimes they read it like this, and sometimes they actually solve it. So you would say 4 squared is 16, 16 times 2 is, right here, 16 times 2 is 32, 32 minus 3 is 29, so 29 plus. 5 squared is 25, times 2 is 50, 50 minus 3, 47, plus. 6 squared is 36, 36 times 2 is 72, 72 minus 3 is 69, plus. And I keep going. 7 squared is 49, times 2 is 98, minus 3 is 95, plus. 8 squared is 64, times 2 is 128, 128 minus 3 is 125. So that is normally how you see that answer in Excel math. The work is what's above it. So that's the sum. Now, here's kind of a trick. If you're doing multiple choice, I wouldn't do all of these. If the first number is 29 in all of them, go for the second one. And then see where they vary, and that's the one you choose. You wouldn't have to necessarily do every term in the sequence. And the last one we're going to do is just looking at a series that looks crazy, right? Doesn't this look really hard? And then I'm looking at the answer. So this is one you only use if you have multiple choice, and I can work backwards. And so what you're going to do is you're going to plug it in and see if you get the first term. So I'm going to say this one says the first term is 1. So I'm going to plug the 1 in here for x. Or excuse me, 1 in here for x. And when I plug in a 1, do I get the first, or do I get the first term? Not x, excuse me. So I'm going to plug in 1 in here. So we're going to have x to the first equals 1 plus 2. So I get x to the first over 3. Is that the first term? It's not. So that's not my answer. See how that works? So then here, the 0 term. So I'm going to plug in a 0. You'll see 0 sometimes, and that's okay. The first term can be 0, the first term can be 1. We'll talk about that more when we're doing our lesson tomorrow. So the first one is 0. I'm going to plug in a 0 for n. 0 here. Denominator is 5. So I have negative 1 times x to the first. Negative 1 times x to the first. Does that look like the first term? It does. Yeah, this one's checking out so far. Okay, I'm going to keep going. And it's 1. I'm going to put a 1 in here. So I have negative x to the second over 6. If this one's not checking, it's got to be over 5. D, I'm going to plug in a 0. I have negative x to the first over 5. That does check, right? Yeah, negative x to the first is negative x. So this one's also a yes. So far, B and D are working. So now I have to check the second term. So I'm going to erase my work so I can keep everything up here for you, but you would just work below this. So now in B and D, I'm going to plug in the next term. So the next term in the sequence is n equals 1. See? So I'm going to plug a 1 in here. I have negative 1 times x to the second over 6. That doesn't work, because when I take the parentheses away, I have this. And this second term is positive. So this one's not checking. So hopefully D checks. So the next term in the sequence is 1. I'm going to plug in a 1 here. I have negative x to the second over 6. Negative x times negative x is positive x squared. Those parentheses make a difference, don't they? That does check. So D would be my answer. So hopefully that makes sense to you. If you have any questions on the lesson, make sure you let me know tomorrow in class.